Hello everyone, welcome back to another video. Today we're going to be looking at the grade 12 physical science November 2022 question paper 1. Before I continue, please press the like button and the subscription button so that the video can be recommended to many more people. Alright, so question 8 focuses on electrical circuits, as we all know. Question 8. Alright. Okay, so the statement of question 8 reads as follows. The circuit diagram below shows 4 resistors. This is the circuit diagram. We are saying it shows 4 resistors. And then they are connected to a battery of EMF E and internal resistance of R. Here's the internal resistor. The resistance of the ammeter and the connecting wires are negligible. So if you look at the ammeter here and then all the wires that are connecting, they are saying, well, you must not consider it or they are ineligible. Alright? They are also specifying that the voltmeters have very high resistances. Voltmeters, let's count them. There's voltmeter V1, then there's voltmeter V2. Alright, let me just explain firstly what do they mean once more when they say the resistances are negligible. Alright, so at the moment they mentioned that we have 4 resistors, but what would have happened if we were to consider the resistance of the wires? Imagine 4 resistors and then you add on top the resistance of the wires, then the whole circuit changes. Whatever current they tell us is going through the ammeter, we must now consider even the resistance of the wires. The one last comment, they are saying that the voltages, the resistances of the voltmeters is very high. If you look at these ammeters, if I was current, I was going to move here, go in this branch and continue here. Now imagine if there was a resistor here, then the current could go this side and go this side. But now they are saying that the resistance of the voltmeter is very high. So if it is extremely high, current at this point, and this side, this current here wouldn't want to go there. No current will want to go that side because there's 2 high resistors. But we'll get on to that. Alright, the first question is asking us to calculate, state Ohm's law in words. Alright, we have here switch S. First question, Ohm's law. Question number 8.1. Ohm's law. How I like to take or tackle circuits in physical science is through equations. You must always remember your equations, but also what you must understand is that all these equations that form in circuits are all coming from Ohm's law. And the very important one is, remember, voltage is equal to I multiplied by R, current multiplied by resistance, or you can flip this around and say current is equal to voltage divided by resistance. Alright, and that is Ohm's law. You can choose to state Ohm's law the first way or the second way. But what does Ohm's law state? Ohm's law states that if you have a conductor, there is your conductor, and on the conductor, current is flowing. Current is flowing, and it passes through point A and point B. Current is flowing through this conductor and passes point A and goes to B. Ohm's law states that the current that goes there is directly proportional to the potential difference between those 2 points. So understand that if in this conductor we were to put in a resistor, it will mean that the current at this point will be dropped, or the voltage at this point A and the voltage at this point B won't be equal. There will be a potential difference. The potential at this point will be lesser than the potential at that point because there's current passing through a resistor. Alright? I is equal to V over I. Or if you have a resistor and then there's current, there will be a voltage dropped on that resistor. Now, the current through that resistor, they are saying that the more the potential difference, the more the current will be. The more the potential difference across point A and B, the more the current will be. And the more the resistance, remember, current has to move through that resistor R. Current has to move through that resistor R. When we say resistor or resistance, when we say something is resisting another thing, it means that it is preventing whatever that thing is from doing whatever it wants. Now current wants to move, current wants to flow, or charges want to flow. Now if there's something that is resisting current or resisting charge, it means that it is making it hard for that charge to flow through, or that current to flow through. Meaning the bigger the resistance, the lesser is the flow of those charges. Alright, so we come back here. Now Ohm's law states that the current through a conductor is directly proportional to the potential difference across that conductor, is directly proportional to the voltage across that conductor, or call it a resistor, and inversely proportional to the resistance. Directly proportional and inversely proportional to the resistance of that conductor, provided that everything else remains the same. So your temperature or whatever, call it the environment that is behaving on. If it gets hot or if it's raining, we are not considering those cases. Then Ohm's law must stand. You can choose to go for Ohm's law through the current formula or the potential difference formula, but for now we'll cover through the current part. Alright, now let's go to the next question, question 8.2. Alright, question 8.2 reads as follows. Switch S is closed and then there is a current flowing which is 3 amps. Now you must calculate the total external resistance of the circuit. Total external resistance of the circuit. Right. First question you must ask yourself, what is the difference between external and internal? What is this thing that is dictating whether something is internal or external? Simple answer, the battery as the source of all this power. This is our battery. This is our battery. Anything that is inside that battery is internal. Anything outside that battery is external. Now when they're asking you to calculate the external resistance of the circuit, they mean everything that is a resistor and outside of that battery. So they mentioned at the beginning that there's how many resistors? 1, 2, 3, 4. 4 resistors. Now I'm going to draw it for you here. Okay, I'm going to just erase this. 8.2. Now this is how that circuit looks like. All right. We have 3 ohms here. We have 2 ohms. We have 1 ohm. And we have 4 ohm. Okay. Right. So they're saying there's current that is flowing here, and you must calculate the total external resistor or resistance of this circuit. Now, when calculating resistance, you must always figure out how is the current flowing. Now, current can go through 2 ways. Current can move in series or can never change path. When you say something is in series, it means that current never changes its path. It is just continuing, call it straight, or just in that same conductor. But when you say something is parallel, can either be 3 parallel lines, 2, 5, or many more. It means that the current will be splitting direction. It will be going this way, and any other way. That is a parallel connection. But now, when you're calculating the total resistance, you must figure out whether these resistors, are they connected in parallel or in series. Okay, now let's figure it out from this circuit. When the current flows, it gets to this point. It's coming this direction, it gets to this point. When it gets to this point, it sees 2 paths. It sees this path here, and it sees this path here. Alright, so it means that at this point here, these connections are parallel, 2 parallel connections. Okay, let's follow this one. Now this current will flow here and get to this point. Alright, now let's follow this one. This current will flow here, pass through this resistor, and get to this point and pass through this resistor. So the question you should be asking yourself, are these resistors in parallel or are they in series? How do you know when they are parallel? Did the current change, or did the current split into multiple directions? Now if you look at this current here, it went through this resistor and continued and turned and went through the same amount of current, flowed here and then went to this resistor, which means those 2 resistors are in series. Alright, now the same current got to this point. Now those 2 currents that split here, if we said this is I, it means there was I1 which flowed through here, then there's I2. Now when they go to this point, I1 and I2 combined again to form that I that you see there. So then it means that when you continue here, you're going to the battery. This current never splits again. So this resistor is in series with everything that is going in here. So how can we simplify this circuit? We can draw it again and add these 2 resistors because they are in series. So you draw a circuit again. You have 2 resistors there, another resistor, then another resistor. Alright. But the question you should be asking is that, what is this resistor? We can name our resistors. We can name this one R1, name this one R2, and name this one R3. R1 is 1 ohm, 1 ohm, and R2 is a combination of these 2 resistors, which is 3 ohm and 2 ohms. So R2 is equal to 2 ohm plus 3 ohm, which is 5 ohms. Alright? Then you have your R3, which is 4 ohms. Okay. Now, how do we calculate the total resistance of this? Remember, we need to break down this circuit till it is literally a series connection. Okay? Now, the only problem here that might confuse one is, how do we take these 2 resistors and make them 1? Or how do we add this resistor to these many resistors here? Remember, the goal is to make everything to be in series. This is already in series with this whole thing, so we must make this one to be in series with that R3. Okay, so it means that we calculate the parallel connection of this. This circuit must be like this. we must simplify this circuit so that it looks like this. Must be R parallel plus R3. All right, R parallel plus R3. Now, how do we calculate a parallel connection, or what is the formula for parallel connection? R parallel, 1 over R parallel is equal to 1 over R1 plus 1 over R2 plus and so on. What is R1? 1 ohm. And what is R2? 5 ohm. So continue 1 over 1 over R parallel is equal to 1 over 1 plus 1 over 5. Then this gives you 1 over R parallel equals to, it's going to be 6 over 5. Then you can solve for R parallel. And R parallel will be 5 over 6. All right, 5 over 6 ohm. Okay. Therefore, the total resistance, which is, we take it from here, total resistance R parallel plus R3 is just addition of those two resistors. Okay, so R external is equal to R3 plus R parallel, which is 4 ohm plus 5 over 6, and you can calculate that. Use your calculator. That is going to be 4 plus 5 over 6, which is 4.83. 4.83 ohm. Good. Okay. Now we move on to the next question. The next question is asking us to calculate the reading on voltage on voltmeter V1. Where is V1? V1 is this. V1 is measuring this EMF here, but what is important, V1 is measuring the voltage here, or the voltage dropped into the circuit. Get me? This voltmeter here, let me draw it nicely, can be drawn like this. You can either put it this way or put it this way. You can either put it here, V1, where you put your resistors like this. Understand that now we have an external resistor here, which we just calculated, 4.8. With 4.81, 4.83 ohms. Now, this voltmeter is measuring at this side, or is also the same voltage that is dropped by this resistor here when a current is passing here of 3.5 amps. Now, how do we figure out the potential difference across this resistor? Because that's what V1 is. Voltmeter measures the potential difference across the resistor. Therefore, V1 then, which is our 8.3.2, okay. 8.2.2 V is 8.2.2. V1 is equal to I multiplied by R external. There's your I, there's your R external, which is gonna be 3.5 multiplied by 4.81, and that is 16.92 volts. 16.92 volts. All right, now let's look over to the next question. The next question, 8.2.3, is asking, how does the reading on voltmeter V2, where's V2? Oh, there is V2. How does the voltmeter V2 compare to the reading on V1? Is it smaller than, equal to, or greater than? All right, let's analyze this. We have two voltmeters, this one V1, which I told you, you can just place this voltmeter exactly at this point. This is going to be your V1. Do you see that this voltmeter is measuring everything on this side? It includes this resistor and this parallel connection there. And then what does that one measure? That voltmeter is standing across this resistor here, or is measuring the voltage dropped on this parallel connection. Remember, the voltage on a parallel connection is the same, but current splits. So, which means that if current is flowing here, there will be voltage dropped here, but remember, there will be another voltage that is dropped by this resistor. And V1 is a combination of this voltage, the potential difference across this resistor, and the potential difference across V2, or across the parallel connection. Let me write it for you. 8.2.3. V1 is going to be the voltage of R 4 ohms there, plus V2, saying that V1 is an addition of the potential difference across this and the potential difference that across this parallel connection. And what is the potential difference of here? It is V2. So the question is asking you, is V2 more or less than V1? And you can see that V1 is V2 plus another voltage, which means that V2 is smaller than. Answer, smaller than. All right. Okay, let's move on to the next question. Okay. Next question, question 8.3. It reads as follows. A learner concludes that an EMF of the battery, or the EMF of this battery, is equal to the reading on voltmeter V1. The first question is that we must define the term EMF. Define the term EMF. Okay. Question number 8.3.1. What is EMF? Okay. Like I mentioned on the first question when we're defining Ohm's law, when you're dealing with electrical circuits or the circuits theory, you need to always remember your formulae. Okay? Now, your formulae tells you about what is an EMF. EMF is related to your energy and the charges. Remember this formula, EMF is equal to energy over Q. Ever seen this formula? Does it ring a bell? If not, please master that formula. What does this mean? It just means that energy divided by Q, or in physics terms, is energy per charge, because Q is charge, right? But what does this mean exactly? Because we're just reading out the formula now. What is energy? You might remember this definition from grade 10. Energy is the ability to do work. You can never work You can never wash dishes if you don't have energy. You must eat something, drink something so that you can have energy. All right. Now, when you say energy is the ability to do work, it means that whatever you are putting in your system is going to give you that energy to then do work. But they are saying that it means that so you are charged of your energy by the work that you've done. Now, this energy per coulomb of charge, which means that EMF, when we mention it, which stands for electromotive force. So this is the driving force, what you put in to have energy. This is the driving force, or the work done per coulomb of charge. It is the force or the energy that this, remember that EMF is on a battery. This is the amount of energy, maximum amount of energy that battery can give to your circuit so that it can push at least a coulomb. So it's a energy that can be pushed, maximum energy that your battery can push per coulomb of charge, per division per charge. Right. So this is the energy or maximum. It is important to remember that this is the maximum. There's nothing more than this that a battery can push. Because you buy a 12 volts battery and that's what it is. It can never be 15 volts, can never be 1000 volts. It will be 12 volts. Maximum energy that can be produced by battery per coulomb of charge. Right? Remember that formula. Okay, let's move on to the next question. Next question, in the learner's conclusion, is the learner's conclusion correct? What did the learner say? The learner said that the EMF of the battery is equal to the reading on V1. Okay. Is this learner correct or no? Now, I told you that EMF is the maximum energy that this battery can produce to push in at least a coulomb of charge. Which means if you go to the stores and you buy a 12 volts battery, that is the maximum voltage or EMF that it can push through. But after 2 years, remember that battery still identifies as a 12 volts battery. But if you take your voltmeter and you measure across that battery, you'll see that through time the battery has aged, which means that it can no longer produce that voltage it promised. Remember, it can no longer produce that voltage it promised when you bought it. Meaning there is corrosion or degradation, or there's particles or rust that is developed in that battery, which is causing it to no longer give you that amount of voltage. And we associate that degradation or rust or that corrosion to the internal resistor of the battery. Which means that if you look at V1, this is you coming with a voltmeter now, and you're measuring across that battery. You can now get 11 volts. But is that the EMF of the battery? Remember, EMF, we said the maximum. Is that the maximum that battery could produce when you bought it? No. EMF 8.3.2. EMF is equal to, you might remember this, I, the current through the circuit, multiplied by external resistance plus internal resistance. When this battery is new, and this thing is always constant, it is the maximum your battery can give, or when you bought it. R external plus R internal. When it is still new, this guy is 0. But as it grows, this guy grows, meaning that the EMF now is being split between two resistors. Now, if you put in your voltmeter, you are reading IR external. R internal. When you put in your voltage, your voltmeter, you are measuring the first guy, because that's the outside, or that's the external circuit. Okay, you're measuring the external voltage and not everything. So the learner is not correct. The answer is no. You cannot say that this voltmeter measures the EMF of that battery. Alright. Answer is no. Alright. You are saying you must give the reason to why we are saying no. I told you that the battery has aged. The battery has aged. Now you can no longer just measure across the battery and think you're going to get the EMF. So the battery has aged and now it has internal resistance. The battery now, internal resistance. Battery has internal resistance. Alright, that concludes part 1 of this exercise. We are now going to move on to part 2. Probably going to continue this one on the next video. Thank you guys. Click the subscription button and the like button so that the video may be recommended to more people. Thank you.